In order to replace these boxes with instance geometry, we'll look for a node that does exactly that. Jumping back into the ice tree, if we look under the geometry instancing category of nodes in the particles tasks, one of the core nodes for working with instance geometry is the set instance geo node, and it should be plugged into the execute on emit port of an emission compound. I don't actually have a geometry hierarchy to instance yet, so I'll open up my browser and I'll bring the advanced rig into my graph. I need to find an empty area to drag it into, so I'll drag in the advanced rig model. And a lot of times when you're dealing with any kind of instanced rig, actually if I just focus in on it or even pull it into my own object view, to a textured decal view and lock down, I've got a fairly heavy poly character here, probably about 10,000 polys. If I do a visibility options on it, Shift S, statistics, and turn on selection, I've got a 15,000 poly mesh. One of the things that's really cool is taking advantage of the XSI operator stack to reduce this character down to something a bit more manageable. I'd want to have any modeling changes appear down in the modeling stack to affect the base mesh. So again, if we just open up that object view and lock, I'll make sure I'm in the modeling tool set and do a polymesh poly reduction. If I lock the controls, I can actually see how the mesh is being reduced, and I get a nice visual on the poly count. So at 0 ratio we have our original poly count, and if I reduce all the way up to say 90% or so, I reduced to 1230, but I don't have a very good layout of polygons. In the poly reduction operator, I can preserve quad lines all the way up to 100%, and there I start to get a better look on my character. I'll keep reducing the poly count to about 1500 polys if I can. And that looks pretty good. That'll represent the Mulcore character pretty well. So all the changes that I've done on the character have been done in the geometry modeling stack, so I can freeze the modeling stack to bake in those changes, and I can now apply this character as an instance to these particles, and the overhead won't be quite as high. I'm definitely going to have to move this character out of the way at some point as well, and a lot of times when I'm working with instance geo, I'll just take the character and sort of find a place well off in the set to move it. I'll just unhide the model node so I can translate the character just off to the side here, or somewhere around the emission point. The emission point is over on this side, so I can actually just slide the character over there. Alright, so at least it's very handy and accessible at this point. If I jump back into the ice graph, I can work with this set instance geometry node now by compound now by plugging it in, execute on emit, and I'll set the instance geometry to point to a hierarchy of objects. If I open up the Explorer, I want this entire rig to act as my geometry instance. So I'll pick the entire rig, and the hierarchy I want would be the object and children. So I'll move back to frame 2, and you can see that at frame 2 we've got our geometry being instanced. The only problem is it's a little too large and it's pointing in the wrong direction. So very easy to fix that. We'll go back to frame 2 and adjust the size of our instances. So if I double click, I have a size set to 4 right now. If I reduce the size to 1, the characters will be the size of the original Mulcore character. The other thing that I'd likely want to do here is you can't actually rotate the model null to rotate the character. You'd want to move the control base of the character. To actually work your way around this, if you have animation that's actually moving forward and you don't want to do any kind of offsets, you could go in and just layer in another a null over top of this character. So you could go in and say get a null, call it something like forward movement, drag it into your model, and make the move all control a child of it. The difference here is that we'll just need to kind of bring this back in again. And I can actually just press enter on this item to make it a little larger. Okay, everything looks pretty good there. And that null is of course in the wrong location, so I'll take the actual null, just move everything apart again here, match up all transforms to the move all controller, move the move all underneath the forward movement, and everything else now sits underneath Mulcore, so that's good. Bring in the set instance geometry, execute it, and point it to the character, object and children. Alright, so we look good now. Keep in mind that we're using the negative Z axis of the character to move everything forward. So I can actually rotate the character 90 degrees to get a forward alignment. So now when I hit play, the characters are moving in the correct direction, and I still have the positive Z axis to work for my instance animation. One of the other neat benefits of working with instance geometry like this is that we get the full benefits of Mental Ray. If I was to unhide my default light, and I'll just move it kind of up a little bit so we can see what's going on, that should work. If I press enter and just enable shadows and turn the umbra down low, to turn my light intensity up, and the aliasing as well. But notice that we get shadows, contact shadows right away. No tricks, no compositing. Just one of the nice features of working with instance geometry in ICE. So that's a good benefit. A nice side benefit anyways. The next step involves actually preparing some motion data for the instances. If I was just to press play right now, I could increase the particle velocity. I'll go to my point cloud, press Alt-9, and if I double click on the particle velocity, I might even want to randomize it a little bit so I have faster and slower characters. So if I actually pull in a randomize node, randomize value by range, plug that into my particle velocity, so they should stop because my range is now 0. And I'll set my minimum range, so if I had -8 as the slowest, or as the average speed, we can use, say, -11 as slow, and negative, let's see, maybe -5. Oh, and actually we're moving in the x-axis, so we'll use, let's just change these around here. Don't know why I was working with the z-axis. So let's have a minimum of 8 and a maximum of, say, 11. Let's go 7 and 11, and we don't want that to be an animated value. So now we should get some characters that are faster and some that are slower. And one of the nice things is that as they're walking, they're also angling themselves and orienting to the climb that they are involved in on that particular slope. So it's actually going to be a pretty fast animation as these characters flow over this hill, but it'll actually look pretty cool. So the simulation's coming along nicely. We just need to get out of this T-pose now, and that will involve a little bit of motor and the animation mixer. So we want to make sure we're doing everything we can here before we move in and start controlling our animation. I'll do a bit of a randomize on size. So again, back in that point cloud, I'll set a random size for these characters. So if I move back to the second frame and pull up a randomize node, optimized value by range. And if our size is 1, then we'll vary around that by, say, 0.8 and 1.1. So we get some short characters, some tall characters, and just a little more variety always works. If we increase the number of characters, you can see how this kind of flushes out nicely after a while. We will make the particles aware of one another using a neighboring forces effect, because they are starting to clump up a little bit too much for my liking. So let's spread them apart somewhat. I'll just rearrange the ice graph a little bit here by adding in a neighboring particles force. So we need to add our forces in somewhere below the velocity. So I'll bring in an add forces compound. I'll add forces to our ice tree, and I'll actually clear my menu here and look in the forces folder to find a neighboring particles force. And all this force really does is take particles that are neighboring one another, and the closer they are, the more it'll try and repel those particles, or attract them if that's what you want. If I double click on the neighboring particles force, we have a relationship between the distance a particle is from its neighbor and the strength which it attracts or repels. You'll notice that as distance increases between a neighbor, the attraction strength or repulsion strength decreases considerably. So I don't want the characters to attract one another, I do want them to repel, so we'll say have a fairly strong repulsion strength. And we'll also make sure that any particles within a certain cutoff distance respect that repulsion need. So we're just going to space them out a little better here. So you can see now they give each other a fairly decent berth. They don't really get in each other's way. We could even increase the cutoff distance some more to really average these guys out as they flow over the surface. Alright, so that's all looking pretty good. I think we'll cut this crowd simulation off here so we can focus on getting the motor effect working first. And then what we'll do is take the animation file that's looped, and we'll displace these characters over time. So we will be coming back to ice to finish the effect off, but we can't really go much further now until we can actually see the Mulcore character moving along the terrain.